A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Dear students, Assalamu alaikum. Today, our lecture is about numerical class 9, subject physics, chapter number 7, properties of matter. Topic of today's lecture, we will discuss about, as we have already done MCQs. Now we are on problem 7.5 to 7.8. We will do problem 7.5 to 7.8, and these are on pages, these problems are on page number 166. I repeat, class 9, subject physics, chapter number 7 we are doing, and the name of the chapter is properties of matter. Topic of today's lecture will be 7. We will discuss the numericals, problems 7.5 to 7.8, and pages covered will be 100, and these problems are on page number 166. Please open page number 166 of your ninth class textbook. This is a chapter we are doing, unit number 7, and the name of the chapter is properties of matter. So this is a chapter we are currently doing, as we have finished this chapter, and we are doing now numericals. 7.5, this is the problem 7.5, class 9, page number 166. Please open page number 166. So I read the numerical statement first. 7.5, problem 7.5. I am going to read the problem statement 7.5. A student passes her palm by her thumb with a force of 75 Newton. What would be the pressure under her thumb having contact area 1.5 centimeters square? I repeat, a student presses her palm by her thumb with a force of 75 Newton. What would be the pressure under her thumb having contact area 1.5 centimeters square? First of all, I am going to write the given data. Force is given to me, as you know, the Newton is the unit of force. So force is given to me 75 Newton. So force is denoted with capital F, and which is given to me 75 Newton. What apart from force, what I am given? Area. Area is also known, which is 1.5 centimeters square. And you know the unit of area is meter square. Centimeter square is the smallest unit of area, but the SI unit of area is meter square. I repeat, SI unit of area is meter square, not centimeter square. Centimeter square is the smallest unit of area, but we need to convert this into SI, system international. The unit of area is meter square. That's why I'm going to convert centimeter square into meter square. How can you convert this into meter square? Because meter square is 2 times, meter square means 2 times. So that's why I centi mean 10 raised to the power minus 2, which is 100. 10 to the power minus 2 is 100. So that's why I'm multiplying 2 times. 10 to the power minus 2, that 100 into 2 times, because centimeter square, meter square, meter is coming 2 times. So that's why I am multiplying 100 by 100. 1.5 divided by 100 multiplied by 100. If it is cube, then I multiply 100 with 3 times, 100, 100, 100. But since it is centimeter square, so in meter, we have 2 lengths. So that's why I'm multiplying 100 multiply 100, and centimeter 10 to the power minus 2. If you take 10 to the power minus 2 under down, it will be 100. So it means 10 to the power minus 2 will be 100. So 100 multiply 100, how many 0 will come? 1, 2, and 3, 4. So 10, I can write 10 to the power 4. If you take 10 to the power 4 on the top, it will be 10 to the power minus 4. So what will be the answer in meter square? The unit of area is meter square, which is SI unit. So 1.5 into 10 to the power minus 4 meter square. Unit of area is meter square, yeah, or square meter. Meter square is the SI unit of area. This is the thing you need to do in this numerical. Then other thing is very straightforward. Pressure is denoted with P. We want to find out the pressure. So pressure is denoted with P, and you know the formula for pressure is equal to force per unit area, F over A. As we know, the formula for pressure is equal to F over A. Force is given to me 75. So 75 divided by area is 1.5 into 10 to the power minus 4. I just found it. 1.5 into 10 to the power minus 4. If you divide this 75 divided by 1.5, you will get 50. And take this one, 10 to the power minus 4 on the top, it will be 10 to the power plus 4. I repeat, force is 75, area is 1.5 into 10 to the power minus 4. So 75 when divided with 1.5, you will get 50. And move this 10 to the power minus 4 on the top, it will be 10 to the power plus 4. So if you convert this 50 means 10 to the power 1, 4 plus 1 is 5. So my result will be 5 into 10 to the power 5, and the unit of pressure is Newton per meter square. Force unit of force is Newton, and area is meter square. So our unit for pressure will be Newton per meter square, and my result will be pressure P equals to 5 into 10 to the power 5 Newton per meter square. Now I'm moving towards next problem, which is 7.6 on page number 166. I read the numerical statement first. The head of a pin is the square of side 10 millimeter. Find the pressure on it due to a force of 20 Newton. 7.6. The head of a pin is a square of side 10 millimeter, and find the pressure due to the force 20 Newton. First of all, length is given to me, which is 10 millimeter. 10 millimeter mean 10 to the power minus 3. So 10 multiplied by 10 to the power minus 3. Because we want to convert this into meter. So length will be 10 into 10 to the power minus 3 meter. So how I convert, when the bases are same, power will be added. Minus 3 plus 1, it will be minus 2. 10 to the power minus 2 meter. So I have converted millimeter to meter, which is the SI unit of the length. Length SI unit is meter. How? 1 divided by 100. So when this 10 to the power minus 2 will go down, it will be plus 2, 10 to the power plus 2, and 1 over 100 is equal to 0.01 millimeter. If we divide 1 divided by 100, it will be 0.01 meter. And you know, in area, because in order to find the pressure, we need two things. First thing is force, and other thing is area. That's why I'm calculating the area. And area, how can we find the area? By multiplying two length with 2 times. Like length is 0.01. If you multiply 2 times, you will get the area. 0.01 multiplied by 0.01, you will get 0.0001 meter square. And the unit of area is meter square. How, if you convert this into scientific, so how many points I'm moving? 1, 2, 3, and 4. So it will be 1 into 10 to the power minus 4 meter square. So force unit is, force is also given to me, which is 20 Newton. So I want to find out pressure in this problem, 7.6. And the formula for pressure, as we discussed in the last numerical 7.5, the same formula we will use in this numerical as well. Pressure is equal to force per unit area. Force is 20 Newton, which is given to me. And I just find the area, 10 to the power minus 4. Just plug in the values, then 20 divided by 10 to the power minus 4. If this 10 raised to power minus 4 will go on the top, it will be 10 to the power plus 4. I repeat, if this 10 raised to power minus 4 will go on the top, it will be 10 to the power plus 4. So you can convert this. So how many 0 with 20? 1. So I can 10 to the power 1. 4 plus 1 is 10 to the power 5. The unit of pressure is Newton per meter square as we discussed in last numerical. So our result will be pressure is equal to 2 into 10 to the power 5 Newton per meter square. I repeat this numerical 7.6 one more time for you. The head of a pin is the square of side 10 millimeter. Find the pressure on it due to force 20 Newton. Since we want to find out the pressure in this numerical, that's why you will use the formula pressure is equal to force per unit area. This is the formula to find the pressure. So what is given to me? Length is given to me, which is 10 millimeter. I converted this into meter because the SI unit of the length is meter. I repeat, the SI unit of the length is meter. I converted millimeter into meter. How I converted? Since milli, as you discussed in the chapter number 1, milli is 10 raised to the power minus 3. I repeat, milli is 10 raised to the power minus 3. So 10 multiplied by 10 raised to the power minus 3. When the bases are same, power will be added. Minus 3 plus 1. The power of 10 is plus 1. Minus 3. When the bases are same, power will be added. 1 minus 3. So if you subtract this, you will get 10 to the power minus 2 meter. The unit of the length is SI unit of the length is meter. So what I did, I take this one and put it down. So 10 to the power minus 2 when it goes down, it will be 10 to the power plus 2, and 10 to the power 10 raised to the power plus 2 is 100. 1 divided by 100, if we divide 1 divided by 100 is 0.01, 0.01 meter. Since for to find the pressure, we need two things. One is force, another one is area. So how can I calculate the area? So one length is given. If I multiply these two lengths 2 times, so it will give me the area. So area 0.01 multiplied by 0.01, I will get 0.0001 meter square. Its unit is meter. Its unit is meter. So meter square. SI unit of the area is meter square. So how many points I'm moving on the left from left to right? 1, 2, 3, 4. So 10 to the power minus 4. It will be the, if we multiply 1 into 10 to the power minus 4, it will be 10 to the power minus 4. So my area will be 10 to the power minus 4 meter square. So force is also given to me. If you look at the 7.6 problem, the force is given to me 20 Newton. So what I want to find out in this numerical, that is 7.6 numerical, pressure I am required. So the formula for pressure is force per unit area. So for force is given to me 20 Newton. You can see this. And area I just found 10 to the power minus 4. Just plug in the values and solve. If you take 10 to the power minus 4 on the top, it will be 10 to the power plus 4. So how did I find 10 to the power 5? Because I moved 20s, 10 for the 20s. So 2 multiplied by 10 for 1, 1 for 20, 10, for 20, 4 plus 1 is 5. So 2 into 10 to the power 5, and the unit of pressure is Newton per meter square. Because the unit of force is Newton and the unit of area is meter square, so the unit of pressure will be Newton per meter square. So my result will be pressure 2 into 10 to the power 5 Newton per meter square. Now I'm moving towards problem 7.7. I read the numerical statement first for you. A uniform rectangular block of wood 20 centimeter by 7.5 centimeter by 7.5 centimeter and a mass is 1000 grams stands on a horizontal surface with its longest edge vertical. Find the pressure exerted by the block on the surface and density of the wood. So A uniform rectangular block of wood 20 centimeter by 7.5 centimeter by 7.5 centimeter and a mass is 1000 grams. Stands on a horizontal surface with its longest edge vertical. Find the pressure exerted by the block on the surface and density of the wood. So these two things are required. First thing is pressure we need to find out and density of the wood we need to find out. Two things are required and we are given volume and the mass. So mass of rectangular block is given to me, which is M. M is 1000 grams. So you know the unit of mass is kilogram. That's why I converted this into kilogram. SI unit of mass is kilogram. 1000 divided by 1000. So 1 kilogram is the SI unit of the rectangular block. Mass of the rectangular block is 1 kilogram, which is the SI unit of the mass. Kilogram is the SI unit of the mass. So you know when we studied chapter number 1, unit of mass, SI unit of mass is kilogram. That's why I converted gram into kilogram. And you know area. It is a uniform rectangular block. That's why I will multiply 7.5 multiplied by 7.5 because in order to find the area. Why I am finding the area? Because in pressure, we have a formula of pressure which is equal to force per unit area. So force is force per unit area. That's why I am finding the area for by multiplying 7.5 by 7.5. Since it is in centimeter, I need to convert this into meter square. How I convert this into meter? Centi is 10 to the power minus 2, which is equal to 100. 10 to the power minus 2, which is equal to 100. So if you multiply this by 2 times, so it will be converted 7.5 when divided with 100, you will get 0.075. 7.5 again divided by 100, you will get 0.075. If you multiply 0.075 by 0.075, you will get 0.005625 meters square, which is the SI unit of the area. SI unit of the area unit is meter square. I was given in centimeter, that's why I converted into meter square because SI unit of the area is meter square. So how did I convert 7.5 multiplied by 7.5? It is a uniform rectangular block, that's why I took it 7.5 centimeter multiplied by 7.5 centimeter in order to find the area. 7.5 divided by centi is 10 to the power 100. 10 to the power minus 2, which is equal to 100. 7.5 centimeters, centi is 10 to the power minus 2. If it is go down, it will be 100. So how many 7.5 when divided by 100, you will get 0.075. 7.5 again divided by 100, you will get 0.075. If you multiply 0.075 with 0.075, you will get 0.005625 meters square. So in this numerical, we are asked to find pressure. Pressure is denoted with P and density is denoted with small d. So formula for pressure is P is equal to F over A. As we know that we discussed this formula in the last two numerical 7.5 and 7.6. We will use the same formula to find the pressure in 7.7 problem 7.7. Pressure is equal to force per unit area. And you know this because we don't have a force. So first of all, we find the force with the help of this formula. F is equal to W and W is equal to mg. I repeat, since we are not given a force in this numericals, first of all, we will find the force with the help of formula. F is equal to W and W is equal to mg. And mass is given to me 1. You can see I converted mass into kilograms. The mass is given to me 1. So I substitute 1. And G value of G acceleration due to gravity is 10. So if you multiply 10 multiply by 1, you will get 10 Newton. Force I found to be 10 Newton. I repeat from here. So for pressure, we have a formula force per unit area. We have found area already by multiplying 7.5 centimeter into 7.5 centimeter, then converted this into meter square. We have already found the area. Now the pressure was not given to me. So I use the formula F is equal to W and W is equal to mg. and mass is given to me 1, and G is acceleration due to gravity is 10. So my force will be 10 Newton. 10 multiplied by 1 is 10 Newton. So same problem here. So I use the formula pressure is equal to force by unit area. I just found force is 10. You can see force is given to force I just found 10 Newton, and area is 0.005625. I just substitute these two values, value of area and value of force, to calculate the pressure. Force is 10 and area is 0.005625. If you solve this with the help of calculator, 10 divided by 0.005625, you will get 1778. And the unit of pressure is Newton per meter square. Unit of force is Newton and unit of area is meter square. If this one will go on the top, it will be m minus 2. So pressure unit is Newton per meter square. Now I want to find out the density. The other thing which I was required is density. So density formula is mass per unit volume. As we discussed when we did the chapter, density is equal to mass per unit volume. And you know we use this formula for the first 4 numericals, 7.7.1 to 7.4. We use this formula, density is equal to mass per unit volume. This is the formula for density. So how can I calculate the volume? And as you know, volume has 3 lengths. Volume has 3 lengths and area has 2 lengths. And first of all, we will calculate the volume, because in the formula we require 2 things, mass and volume. So how can I calculate the volume? So previously I was given, if you look at the problem 7.7, you will get 20 centimeter by 7.5 centimeter into by 7.5 centimeter in order to find the volume. So I will multiply this. First of all, centimeter is converted into meter. This is the unit of volume is meter cube, which is SI unit. First of all, I convert centimeter into meter. So 20 divided by 100, 7.5 divided by 100, centi is 100, centi is 100 if it is go down, 7.5 divided by 100. So I multiply this, 20 divided by 100 is 0.20, 7.5 divided by 100 is 0.075, and 7.5 is divided by 100 is 0.075. If you multiply this 0.20 multiplied by 0.075 multiplied by 0.075, you will get volume 0.001125. And the unit, please write down here, meter cube. The unit of volume is meter cube over here, because I have converted centimeter into centimeter cube into meter cube. The SI unit of the volume is meter cube. So please write volume is equal to 0.001125 meter cube. Student, please write over here meter cube. So density formula is mass per unit volume, and mass is, I just found previously, I found mass is 1 kilogram, and volume I just found here 0.007125. If you substitute these two values, value of mass and value of volume, you will get 888.8. If you divide 1 divided by 0.001125, you will get 888.85. If you round off this one, you will get 889. And the unit of density is kilogram per cubic meter. As we have discussed, the unit of density is kilogram per cubic meter, because the unit of mass is kilogram and the unit of volume is meter cube. If you shift on the top, so it will be -3. So the unit of density will be kilogram per cubic meter. So the things were required in this formula, in this numerical, was pressure, and pressure is 1778 Newton per meter square, and the density we calculated is 889
मेरे
kilogram.
फिजिक्स के सर की आवाज सुनो नेट मी से इसके बाद क्या करना है आपने इसके बाद मैं आपको पूछे
7.8 numerical. First of all, I read the statement of the numerical. A cube of glass 5 centimeter side and mass is 306 gram, has a cavity inside it, If the density of glass is 2.55 gram per centimeter cube, find the volume of the cavity. I repeat, the cube of glass of 5 centimeter, side and mass 306 gram, has a cavity inside it. If the density of glass is 2.55 gram per centimeter cube, find the volume of the cavity. First of all, I read the given data on page, this is on page number 166. The numerical number is 7.8. Length of side of cube is given to me, L, which is 5 centimeter. And the mass of cube is also given to me, 306 gram. And the density of glass is also given to me, which is 2.55 gram per centimeter cube. Gram per centimeter cube. I repeat, three things were given to me. One, length of the side of cube, which is 5 centimeter, and mass of cube is 306 gram. Density of glass is 2.55 gram per centimeter cube. These three things are given to me in problem 7.8: length, mass, and density. What I am required, find the volume of the cavity. The volume of the cavity is noted with V, and you know the formula for the volume. I use the same formula. Density is equal to mass per unit volume. If you want to find out the volume, so you will divide this with density. Same formula, density is equal to mass per unit volume. But in this case, we want to find out the volume. So separate out volume. So the formula will be V is equal to M over D. I use this formula so many times. 7.1 to 7.4, same formula we will use in 7.8 numerical. Mass is 306 and density is 2.5, 2.55. Students, this is 2.55. Please correct this one, 2.55. 306, 306 divided by 2.55, you will get 120 centimeter cube. You don't need to convert this into meter cube because our answer is in centimeter cube. That's why we are not converting this into meter cube. And the total volume, how can we calculate the total volume? You know, in volume we have three lengths. So one length is given to me. If I multiply 3 times, I will get the total volume. 5 multiplied by 5 multiplied by 5. 5, 5, the 25, 25 multiplied by 5 is 125 centimeter cube. Student, in this numerical, you don't need to convert into meter cube because our answer is in centimeter cube. That's why we are not converting this into meter cube. And the cavity is a very small quantity. That's why you don't need to convert this into meter cube. How can we calculate the volume of cavity? Total volume is, subtract total volume. 120, total volume is 125 and the volume of glass is 120. If you subtract 125 minus 120, you will get 5 centimeter cube. So our volume of cavity will be 5 centimeter cube, which is the required result. I repeat, 7.8 numerical. First of all, I read the statement for you. A cube of glass 5 centimeters size and mass is 306 gram, has a cavity inside it. If the density of the glass is 2.55 gram per centimeter cube, find the volume of the cavity. Length of side of cube, first of all, I write the data. Length of side of cube is 5 centimeters given to me. Mass of cube 306 gram given to me. Density of glass is 2.55 gram per centimeter cube. This is also given to me. These three things are required given to me. And what I want to find out, I want to find a volume of cavity. Volume of cavity, you know the formula for, in order to calculate the volume of glass is, I use the same formula which I used in the couple of numericals, 7.1 to 7.4. Volume is equal to, formula for volume to calculate the volume is mass per density. Because the formula for density is mass per unit volume, because I want to find out the volume, that's a separate out volume from that formula. Same formula, density formula. Density is equal to mass per unit volume, but we want to find out the volume, separate out V is equal to M over T. So just plug in the values. Mass is 306 and density is 2.55. Please write 5 here. Instead of 2, write 5 here. There's a small mistake. 2.25, instead of writing 2, you write 5. 2.5, 306 divided by 2.55, you will get 125 centimeter cube. You don't need to convert this into meter cube because our answer is in centimeter cube. Volume, total volume, how can I calculate the total volume of block? Is 5 centimeter multiplied 5 centimeter multiplied by 5 centimeter. Is gonna be 125 centimeter cube. So in order to find the volume of cavity, you subtract the total volume, subtract 120 volume of glass from the total volume, and the total volume is 125 minus the volume of the glass, which is 120. I just find 120. So if you subtract 125 minus 120, you will get 5 centimeter cube. So volume of cavity is 5 centimeter cube, which is my required result. Student, this is the end of the numerical 7.6 to 7.8 with 7.5 to 7.8. In today's topic, we discussed numerical 7.5 to 7.8. I hope you understand this. If you still have questions regarding today's numerical, please feel free to ask questions. Practice homework is 7. Practice solve problem 7.5 to 7.8. On rough register, first of all, you do it on rough registers when you feel comfortable and you can solve by yourself. Then transfer them on neat registers. One time on rough register and one time on neat registers. I will check the neat register. So if you have any question regarding today's lecture, if you don't understand any part of numericals from 7.5 to 7.8, please feel free to ask questions. I'm here to answer your question. Thank you. Muzna, do you have any question? Students, if